of the session.
Yes.
First thing is make sure that team understands next week we won't have this session.
Okay.
Right, because we have our meetup, so make sure all the team is registered in Eventbrite and joining the meetup, cybersecurity meetup.
Okay.
Right, so we don't want two programs going at the same time, right?
Fair point. Fair point. Yeah.
So that's one thing, and the yeah, that's more or less right. So actually, I mixed both the things together. One is next meetup, ask them to join, and the second one is we won't have this session next week. We'll have 1 week break.
Okay. Thank you. So that's what are anything else?
No, these are the two things.
Okay.
I'll be online, but I will join the other call if it is okay.
No rush, no reason, man. Take it easy.
Sure, thank you.
I think we can start, Krishna. It's 10:35. So
Okay. Just 1 second. Let me clean up my slide.
yeah. And I'll monitor the chat. If there are any questions or anything, I'll let you know.
Okay. Thanks. Thanks, Sir. Okay. Let me start my presentation. Good morning, all. So I'm Krishna. I'm the presenter for this series of sessions. We started stating it's AZ 900, but I think we are going a bit more deeper on multiple different areas. So to quickly run through what we have covered in the past week, we started with the basics to Azure, and then we went into looked into AKS. Looked at DNS and private DNSs, load balancer, application gateway. We had a very detailed overview about the storage. We split them into two parts. We covered pretty much the end-to-end storage types of storage available in Azure, and it's week 8. Thanks for attending all the sessions. If you want to go back, Mickey does a fantastic job of hosting the content and getting up to so that you can always listen to offline. So this week we're going to focus on one of the key, I would say, aspects in the cloud world, which is storage, like data storage. So the way we address it as a modern data estates. So it's actually there's a two-part series. So the first part focuses on the databases like Cosmos, NoSQL type databases, and also relational data store. And then basically what we do is the following week we will look into the marketplace and things like that. Looks like I've made a mistake on the week numbering, so I'll fix that up. So apart from that, the additional sections we are going to look into is IoT, artificial intelligence, as well as serverless compute, and DevOps, and Azure governance. So potentially, I'm looking to finish this by mid-August timeframe. And then, so these are the things which you've planned for the future, depending on the timelines and presenters. We're definitely going to have a Kubernetes workshop for the students, as well as And there are new types of frameworks have come into existence from Microsoft. So one is called the Cloud Architecture Framework, as well as the Data Architecture Framework. So I'll catch up with my team, with Kadir and my other directors to how to get them materialized. The reason for those types of frameworks is basically learning about individual pieces of technology is one, but how do you going to take your how do you transform your customers? So the framework with Microsoft released it, I co-authored some of the contents as well, so that's available. So looks like we're going to have a very impact session all year round. So let's quickly go into the modern data estate. So if you have any questions, any use cases you want me to touch base on, as always, ping in the chat window. Shad is going to watch out for it. Irrespective of it, you can always leave a question, and then I will do my best to respond to it. So let's look into what are the fundamentals of the whole idea of data estates is basically it's for customers' needs in terms of storing data at cloud scale. So the reason about data, why we call it data estate, is basically the conceptually these days the applications are not built with one single type of databases or data stores. It composed of multiple different types of data storage systems, depending on the type of the data you're going to store. If you're storing pure text, pure videos and pictures and images of the likes, you might store that in blob storage, which is basically large object store systems. But if you have no unstructured database data, then you tend to store in a NoSQL type data store. But still, majority of the businesses will have structured data store. Mostly for the transaction integrity, able to query faster, able to build relationships through that. So that's where the databases like MySQL, Postgres, and also something like SQL Server all comes into play. So the term we use is called data set because it's the reason is it's composed of multiple different types of sources. Before I go into it, I really want to start off with a very key security or networking model that Microsoft Azure has built around this. We call them traditionally what happened is when you have a PaaS, platform as a service type data store, the endpoints are accessible through the public internet. Okay. So there is nothing wrong with it, but a lot of customers don't like the option of accessing the services through a public endpoint. Okay, so one of the challenges or security challenges the public endpoint might pose is because it's got a public facing IP address or public facing URL that can be potentially be maliciously taken advantage, and then you might have other issues follow that. So what Microsoft as of today is doing is we have a functionality called private link. So what private link does is makes your publicly available database into fully private, makes it fully available only to the private network connectivity, which means your RFC 1918, which is the 10 dot and 170.192 dot IP or ranges can be attached to this endpoint, and these databases will start to behave as if they're fully private and living with your network. What that gives customer is first and foremost all the public endpoint for this particular deployment of the services is basically it's not there anymore. The second one is from a security and compliance perspective, it makes very easier. Are you guys still hearing me?
Yeah, we can hear Krishna.
Okay.
Yes. Krishna, yes.
Fair enough. I had some, I think looks like something timed out. So this is a very key concept to know, because the reason I'm bringing this at the front of the class is to ensure So all the things that we are talking today is basically enterprise grade, privately available data store, not public endpoint data store. There's nothing stopping you from making these data stores as public, but for the context, we're going to talk about the enterprise grade private endpoint data stores. And the whole concept on it, it's we need a dedicated section of how we able to achieve this through our engineering capabilities. So but that's for another day or another session. But this is to understand, to make the the net from the network security perspective, you're looking at a private endpoint databases. So I think previously we touched base on this specific concept of modern data estate. So we have three classifications. One is any type of operational data store, data warehouse, and data lakes. Those we call as a BI store. And then the top one is about artificial intelligence and machine learning models as well. So the concept has changed. You know, people tend to use data lakes for certain types, but the new term that we starting to use is called data estates. So within Azure, we have the three. We segment this into three major buckets. So one is if you look at the data, there are 2, 3, 4 areas that we specifically look at. Let's go from the bottom up with basically cloud scale analytics. So one of the mandate of Microsoft in terms of the data storage is ability for customers to do cloud scale analytics, irrespective of the data type or data store or what type of it doesn't matter you have no SQL type or it doesn't matter whether you store in blob, you should be able to give a very cloud scale analytics capability, and all the data are more globally distributed data, right? So one of the challenges, as based on my experience, a lot of these data stores are basically built with in a replication model between a primary would be there, and you have a secondary data store sometimes, or you have a master, you have a slave. So basically, at any point in time, the master is the one which dictates all the data sources, how the integrity is maintained. The slaves tend to get data much more later stages. So one of the mandates within Azure itself is all the data stores that we talk about are globally distributed data, which means from availability, from a perspective of scalability, it's out of the box. And also another couple of use cases which I see is there are within data modernization to Azure and also data modernization on premises. So a lot of Microsoft is one of the cloud vendors, which basically we focus mostly a lot of the use cases on the hybrid use cases, because when customers move to cloud, they not only move into the cloud area, but also they still want to keep the on-premises footprint extensively. So our data products that we build for customers have linkages back to the on-premises systems without affecting the cloud-based systems as well. So as a hybrid vendor, we offer tools. For example, if we look at Azure Arc for databases, it has got ability to manage databases on premises too. And the AI piece is extremely important. So all the products, most of our data products have AI capability as well as machine learning capabilities baked into it. So just for this will help customers to not to look at AI or ML as a separate entity, but part of the ecosystem itself. When you have the solutions as part of the ecosystem, makes your ability to scale, to do more analysis at much faster pace versus it is not a separate entity. And also from security aspects of it, you're not copying data into multiple locations or multiple stages. It's just basically it's a single frame of glass in terms of AI and ML. And the last one is we call them self-service BI and on-premises BI and apps with intelligence. So if you take about these two, if you might heard of things like the Power BI. Power BI is one of the solutions which works on the cloud as well as on premises. And there are a lot of applications within Azure which has got basic intelligence capability built into it. So we will cover those things on the part 2 of the session, but let's go into the details of it.
Sorry, Krishna, there's a question by Ajit. What's data modernization?
So data modernization can be classified into a couple of areas, right? So if you're a traditional company which has got a lot of multiple smaller subset of data, right? Most of these data would be stored on systems like a virtual machine layer or a server layer and things like that. So when you talk about data modernization, what we'll do is we will help you to move these traditional data store as it is, but the underlying infrastructure capabilities, we modernize it using cloud native capabilities. For example, one of the challenges customers used to have is they would be running a huge SQL Server environment running on 6.5 or the old traditional ones. So what every time a new version comes in, they are forced to upgrade to the next version, and which means it also incurs two things. One is currency, we call them actual dollars are spent to do the migration, and the other thing is also you also need to change your applications and things like that to make sure that the new version of the database tend to work the old way, right? So what we do is we help when you say modernization, what we do is we help you to remove the cost of maintaining these systems. At the same time, we will also make your application more robust by making new capabilities available into your transform data stores. Okay. It also gives one additional capability is because when we move into the cloud, when you modernize your data sets, what's going to happen is it's going to get you new cloud capabilities, and also that extends your functionality and mechanisms to a larger extent. So this is to put it very simply, we are able to maintain your business operations as it is, but we will change everything around it to make sure you're able to continue your business, but at the same time you get new capabilities into your data stores. A lot of the customers as of today are looking into cloud native databases without interrupting their existing processes and procedures. So that's where it is. So we can go into details on it. I think if you think about it, I'll give you two keywords. One is reducing currency challenges. When you say reducing currency challenges, we are going away from versioned data stores to sort of unversioned, fully cloud native data store. The second one is the reduction of overhead cost associated with operational expenses. We removing you from the concept of patch management, upgrade cycle, and also totally removing the infrastructure underneath that. If you have any clarifications more than a question on the window, I'm more than happy to answer that. So I think one key point which is we touched earlier is about the insights at CloudScale, right? So on the left-hand side, you see like things like unstructured data stores, structured data stores. So if you think about the ecosystem, this is where we're going to cover in part 1, part 2. So the traditional ingest would be based on an ETL tool. You might be using things like Informatica or some sort of a processing tool, which you tend to procure it on its own, and then that will be used to ingest data into your data stores, right? So in the cloud world, we have products like Azure Data Factory. So as the name implies, it's basically a data factory where it's going to consume irrespective of the type of data, and it can consume those data and then push that into a large volume data store, which is the blob storage in this scenario, which is ADLS Gen 2, as we saw earlier. So once the data lands into it, next to do is preparation of the data, right? So this is where most data architects as of today spend most of the time is how do you prepare the data to make it ready and for storing it for a long-term archival system, right? That's where the data warehouse comes in. And one subsection of the data warehouse is also called Azure Synapse. That's a new product which encompasses all these things into a single product framework. And the last one is reporting, right? So the reason at the end of the day, your data is, as we call data, as the new new oil and things like that. So where the data is going to give value is when you have the ability to get insights out of the data store. So one of the advantages of using cloud is basically making the data more valuable. So this is where when I talk about modernization is So traditional data stores, you can still do these sort of analysis, but it's always broken processes. But when you use something like Azure, it's able to give you the insights natively out of the box and with low cost as well, because when you see the flow, it looks like individual flows, but actually these are very streamlined from end-to-end processes. And the main thing is you can fully automate from ingestion to reporting with scripts and ARM templates and Terraforms and PowerShell, the whole lot. I think we briefly touched base, so let's go deep dive on each one. One of the reasons why you should think about Azure Data Factory is it has got pre-built connectors. For example, if you have SAP, if you have Amazon S3, you have Google Storage, if you have on-premises, if you have Hyper, and doesn't matter what it is, it comes with the pre-built connectivity. So when you think about pre-built connectivity, it also means one thing, which means these connections are tested and proven it's going to work, which means you don't have to go and test yourself and make sure it works and things like that. And the second one is storage. I think Azure Data Lake Store is one of the storage systems which has got highly scalable, and it's available in multiple data centers and high resilience systems as well. And Databricks is about Spark. If you know about what Spark is all about, it's basically Spark is a processing engine. It's a managed service, which means you don't host infrastructure, but all you do is run Spark on it. It also gives you one major advantage because this is a fully baked in platform as a service solution, which means you don't have to ever worry about any of the underlying hardware or servers. Is basically available through as a service. And data warehouse is basically able to store your data store and in a SQL form where you can do data, any type of analytics on it. And the last one is Power BI. So Power BI is our standard standard business analytics tool, which is available both on the cloud version as well as on the on-premises version as well. Let me enable that. Okay, go back. Okay. So this comes. We come to a very important section, which is of today's topic. So if you take about Azure, the Azure is not about a specific service, or it's not about individual capabilities, but Azure is about transformation of your business, or transformation of your product, or transformation of your services into a cloud scale model. If you think about just purely on the data services layer, we have multiple different types of data services based on needs. Starting from data warehousing, which is for your archival, which is for your long-term analysis, Azure SQL databases, which are basically a platform as a service database, which is SQL. If you have done work with SQL Server, it's basically a cloud version of it, but much more better capabilities. And we also started introducing things like Postgres, which is again a relational data store. It's an open source database. And also we talked about MySQL, which MySQL is again is an open source database, and MariaDB. So these are the four. I would say these 5 services are available for customers purely from the relational store aspect. You might wonder, okay, I don't have any of these things. Can I do other things too? Yes, you can deploy an IBM DB2s, Oracles of the world, Sybase, and things like that. There's nothing stopping you from it, but those will be deployed as infrastructure as a service. But these are services natively available as well. So if you think about it, I just want to see on the right-hand side, global region availability, right? So the point of having a data store is not the services, but is it widely available? Is it you're able to use the same service in multiple geographies? The reason why we need to talk about geographies, when you talk about data store, there is always the compliance and resiliency, as well as the residency requirements are very key. So a lot of the applications or solutions you build have to live on a certain region because of compliance and audit reasons. For example, in Canada, there are a lot of government compliance where data cannot be stored in the US, even if it's going to be a caching system, right? So everything has to reside within a region. So that's why the services we talk about today are available in all regions, in both our regions, Canada Central, Canada East. The underpinnings of the data services are two key things: storage systems, which is where, if you think about, if you take multiple layers of it, at the end of the day, these have to be stored somewhere. So the storage systems plays a major role, and compute, because so databases are not independent by themselves. They need a very strong compute layer. Depending on your capability or depending on your requirement, we also need to provide you with enough compute that you're able to process it. On top of that, you're able to have additional capabilities like scaling out or horizontal scaling or vertical scaling, depend on your requirements as well. If you take the if you come to the other side, which is the Power BI app services, data factory, Azure analytic services, machine learning, cognitive services, and bot services. So the reason for these services is these services have inbuilt capability to access any data store within the security framework we defined, right? The reason I'm calling security framework is every time a request is being made from one of these services, like Azure bot services to a data store, security plays a major role. Whether we have to see whether the process that is requesting the data store is actually authorized to go and pick up the data. When it does it do through a proper authentication authorization mechanism, and it also, most importantly, the service which you're requesting, is it efficiently able to process the information and then put the results in and then sever the connection once the job is done, right? The reason I'm mentioning about security is, and most of the Azure services run with least access privilege model. So which means you can always configure the service with the least access that is necessary for doing the job done, right? So we're just deviating the security, but to make it very clear, the services are built with that concept in mind. So all the data services in Azure have the direct affinity towards the native services, and it gives you one single thing. If you think about security posture, the security flows smoothly. And also other additional concepts like distributed transaction logs also makes a very key point. For example, every time a service accesses a data store, every single transactional aspects of it stored for multiple reasons. One is for security and compliance and audit, and also from troubleshooting purposes.
Krishna, sorry, we have a couple of questions.
Yes, please.
There was one asked earlier by Ajit again, how customers balance between modernization and privacy?
That's okay. That's it's a multi-layer question. Let me ask when you move from your on-premises world into the cloud world, and when you modernize your systems, we need to really understand. First and foremost, we will do is understand the type of data which this particular system is holding, and what are the pros and cons of hosting them into the public cloud, right? Because I think in the context of privacy, there might be, let's say, if you take this data store that you're trying to modernize has got some PII information, right? Personally identified information. So depending on the company enterprise needs, they might impose, if you want to host this data into the cloud store, you need to make sure the data, there's no critical information about the particular customer is exposed, and all the information has to be encrypted at rest, right? We have transparent data encryption, column level encryption, or field level encryption. Depending on the type of encryption you want to do, you need to do that. Some customers also impose tokenization. When I say tokenization, what happens is they will take certain columns or certain fields out of it, they will tokenize it and keep the source in on premises. When it goes into the cloud world, is basically you'll have like a I wouldn't say garbage information. You won't be able to identify the information using what's stored on the cloud. Sometimes customers also do is, okay, you know what, you can move only 3 or 4 attributes into the cloud. Rest of them may have to keep it on premises. So depending on that, we can do that. So to short answer your question is, it also goes with the type of the data store. It also goes the type of information that is actually stored in the databases. It also imposes some companies. Let's say if you're running a web application company, right? If you're running a shopping site, absolutely you need to keep your customer information, pretty much everything closer to your compute. In this case, you have a different mechanism of security as well. So if you're wondering, what other enterprises do, most enterprises, they always go through this sort of a loosely process like this. They'll find out from a data security aspects of it, what are the mandates. They also think about how to do encryption. They also look at identity in terms of who accesses it, what accesses it, enforce some security policies. And also in the cloud world, we can always do one thing, right? We can block the full internet access to this data store by putting firewalls, boundaries, audit controls. An audit control won't protect you from accessing it. We can put a very strong boundary against it, so which means Azure becomes an extension of a data center. So that's a very good question. I can send you some a couple of publicly available white papers for you to do it. I would say always goes by application. Having said that, a lot of enterprises are able to move by defining a very strong data governance policies, right? In Azure, we have a feature called Azure policies. Using Azure policies, you can enforce a lot of governance into that, into your solution, into your resources. So that way your data privacy rules are also validated across. So customers are able to go through that without any challenges. I will send you some information on how we do at Microsoft and what are the things that you can consider on it. That's a very good question. Thank you. Hopefully it answered your question. If not, I'm more than happy to. So you had a couple of questions, Shad.
Yeah, one more question from Hetal. Does Azure Data Factory have some auto ETL kind of process which can be scheduled and run in scheduled time for data transfer?
Yes, so that's a good question as well. If you go into the Azure AD, we also have it has got a timer control. It also got features like automatic scheduling, and it can also, if you know what, it also has got one other feature. You can have Azure batch jobs. You can trigger batch jobs from on-premises and things like that. And on top of that, it also has, you can trigger Azure Data Factory from an external service, okay? And that can be used to, we call them as scheduled triggers that can also be incorporated into the Azure Data Factory as well. Hetal, I will send you some information. The keyword is called scheduled triggers, which you can actually, basically what you do is you define a pipeline. In the pipeline, you will say, run this pipeline every hour or daily, or you do it based on your schedule. You can do that. You give a time in UTC format, and then you specify recurrence. And then based on it, it's going to run. And also, sometimes some customers say, I'm running all my processes on using my on-premises tool or scheduler. In that case, you can call the API of ADF and then run it. Yes. Short answer to the question is yes, it is possible, and it's native feature in that ADF.
Right. You can continue, Krishna. That's a question.
Thanks, Hetal. So I think it's connecting to the previous question that was posed. What do you call modernization, right? So at the time I didn't touch base on the feature called the database migration service. So traditional databases like legacy SQL servers or Oracle or Teradata DB2, they're also open source, which is widely used as MySQL, Postgres, and MariaDB. So customers could do multiple choices. In the very left, you know what, they will do lift and shift. You know what they do is they take the databases as it is, and then they copy the database as with the existing form, and they'll deploy a virtual machine on top of that and put that into the, and then just deploy. Very standard stuff. With nothing different than your existing model where you're deploying a new servers. If you think, if you ask me, hey, whether this is the optimal approach, sometimes it is, sometimes it is not, depending on how you as a customer wanting to treat this modernization, right? For you, moving from a physical server to a virtualization might mean modernization. In that case, it's not true modernization, but still do it. Nothing wrong with it. It's a lift and shift scenario. But you will not be able to get the full capabilities of the cloud, but you will get some capabilities of the cloud. For example, you don't have to worry about the underlying virtualization layer anymore. You might not need to run Hyper-V or VMware. Azure does it for you. If you think about the other use cases where, you know what, I don't really need to care about anything. All I need to care about is I need to only worry about only one thing, my data. Okay, and then in that case, what you do is you use a service like the data migration service. You give the source, hey, this is my SQL database. You take a full dump of the data store, copy that into the Azure managed instance or a SQL, we call them a SQL MI. Boom, that's it. Your database is deployed into the cloud world without you needing to worry about infrastructure anymore. And also it gives you some nice capabilities. Okay, DR baked into it right out of the box. Replication into a secondary region, yes, out of the box for you. Switching between primary and secondary, yes, you can flip by the click of a button or automated process. All of a sudden, the magic happened is, oh, no more infrastructure installation. Don't need to worry about hypervisor. Don't need to worry about patches, fixes. But the best advantage of the other is we give you compatibility between your legacy older versions of the SQL, right? Which means you might be running on a SQL 2012 or the latest, or certain types of versions. All of a sudden, the SQL MI is going to give you compatibility nature. And one other thing you have to understand, in the cloud world, the traditional versioning is all gone. You won't find SQL MI 2019. You won't find SQL MI 2020. Basically, the SQL MI version and versioning is pretty much gone. A lot of customers, you know what? I don't use SQL. I don't. I run my own MariaDB or Postgres or my MySQL type data store, right? So what we do on those scenarios, okay, you can still we offer you the data migration service, and also you can run these open source databases as a managed service on Azure. So I'm going to show you a couple of versions, which is available for you to use. What that gives you is one main advantage. These databases, when you deploy them, they all have the challenge of physical infrastructure deployment, especially when you took out MySQL. It has got its own way of making replication available. How do you make it highly available in multiple data centers and things like that? So a lot of challenges comes onto that. What we do with Azure is we make it extremely easy and simple for you to manage them. And the last one I would say is oracles of the world. If you have Oracle, we can always convert that into a SQL. And if you have any Teradata, we can help you to convert them into SQL, or any of one of your Postgres or MySQL or MariaDB. If you have DB2, obviously yes. So in summary, if you think about pathways of modernization, I would say there are three ways to do that. So the first one is basically going with lift and shift option, where you deploy the servers as it is on the cloud. You don't do anything. You just make it. You just remove the virtualization management layer, and then you make it available on Azure. When it comes to Azure, it gives you features like backups. Backups are basically available through automation by the Fabric. The second one is, we have managed SQL instances, which is basically behaves exactly like SQL Server, but fully managed. But if you don't want to use, SQL type products, then you can go and do a managed, Postgres, MySQL, or MariaDB. So this is the path to modernization. and some customers use mix and match. And we offer data migration service, which means basically we can take the data, and then the target can be one of those, one of those or two of those solutions that you find. The next one I want to talk about it. Yep.
A couple of questions again,
Yes.
Krishna.
Yep.
One by Hetal. Does that service do real online production data too?
Yes. Yep. It doesn't matter. We don't. When you say migration, I think what she might be maybe asking is, we can do either two times. One is real-time migration, which means the data is actually synchronized in real time, pushed into Azure, or we can do offline migration mode as well. So depending on the use case, we can do that.
Right. Next question is from Ajit. For data migrating to Azure, what are the things customers should be aware of from a price point of view?
That's also a good question. So a couple of things, right? So when you go from your on-premises to cloud, there are a couple of things. For example, how does your licensing model is going to work on the cloud? In the cloud, there is nothing called licensing from the if you go to the native service like Azure, SQL MI, or or the Postgres or MariaDB and things like that. So that's out of the box for you. If you use SQL servers, we also, depending on if you are a software assurance customer, you get credits for moving into Azure, which means you can still, all the money you paid for the licensing can be carried over depending on a certain clause and conditions. Some customers try and deploy their server, so-called database servers onto cloud. The company which is supplying your software might charge you certain fees for the service to move into cloud, and also they might charge you per core. Some companies do that based on this one, and also see that's licensing cost. And there's also migration cost. When you migrate it, you have to pay. You need to understand how much is going to cost to move. The database migration is not only database migration, application also we need to move, and also how do you backups are managed on premises versus how do backups are managed on cloud. So cloud gives you options like cheaper storage and things like that, and also what are the downstream applications that you need to take care, right? So because when you're deploying, you have databases, most of them have downstream application that has to be taken care. On the cloud world, we also impose certain restrictions and rules and policies. For example, if you used SQL, you can always have a local username and password, right? On the cloud world, we don't recommend you do that. We want you to use a cloud native usernames and password, which means there might be changes in your security posture. So which means you have to change. If you're always using SA in your application, we're using SA in the passcode, which is totally wrong. You should not do that. In the cloud world, we'll insist you not to do that. Encryption, right? In the on-premises, you don't care about encryption. When it comes to the cloud world, you should have encryption on the certain fields, right? So depending on your use cases, there might be definitely cost. But do note, a lot of these things are one-time costs. So once you move that, you're pretty much once you move fully into the cloud world, your cost will be substantially reduced. Yes, that's how I see it. Yeah. So there was, I think Hetal was. Let's say I'm running in some online booking application. I want to move from on-premise Azure. How should I do that without losing any latest data? That's a good question. I would say, there'll be two phases for it. Okay. So the first phase, I'm just talking purely on data, right? It's called one-time load, OTL load, right? Where your data is you taken from the source to destination, you dump it as it is, and you get your database up and running. And what we also do is we also do OGL too, right? Ongoing load. So ongoing load is very interesting because till your application is fully cut off into the cloud world, we end up building an OGL process. Okay, the OGL process usually I tend to build using Spark or some sort of like a fast ingest tool using a PaaS service where what I do is I'll keep your data synchronized as as and when changes happen on the backend system, they'll be pushed into the cloud. But at a certain point in time, I'll always have a cutover, which means when I do a cutover, there might be gap of 1 or 2 hours, depending on how critical the application is. During the cutover, what will happen is the new data store will get all the requests, and the old data store would be basically I'll cut them off from any updates. And then after a certain point in time, after 2 hours, my cloud data store becomes the latest and the greatest, and I will just basically decommission the old ones. So there are various process methodologies we do. Then again, if you use Azure Data Factory, Databricks, or a combination of that, you can make these cutovers very easy. I've done large, multi-million-dollar migrations in terms of websites, in terms of news channels, and also shopping sites without having any major issues. But a lot of planning has to go, because you need to know which data store has to be replicated, which tables cannot be replicated, what are the meta stores. But planning has to go. But in summary, we adopt 2 strategies: one-time load (OTL) and ongoing load. So depending on how we build the process around it, we can do that efficiently. So I think, okay, I'll quickly, I think Shad, I'm going to spend a little more time on the question from Hetal, which is really good. So
okay.
So if you think about traditional Hadoop type data stores, right? What happens in the world of Hadoop, everything is done through the way of like you have a data. The data would be split into smaller chunks and split into and thrown across your data, your large volume disks. And then that way you're able to have distributed storage systems, and which make your life easier, right? So one of the challenges with that, in my view, is because the way this Hadoop is built was a very massive ecosystem to manage and build and things like that. So actually Spark was built in University of Berkeley AMP lab. So one of the mandates of the Spark is to be able to build it's a computing framework. So what happens with that is it do 2 things for you. One is it gives you massive data parallelism, which means you're able to process data at high velocity using parallel processing engines. The second thing it also did is it had a very key concept called resilient distributed data sets. So basically, if you think about RDD, it's basically a read-only copy of data is kept into multiple clusters. So in a massively fault-tolerant way, which means what happens in Spark engine is your memory is massively used for processing versus your disks, which means you don't have the challenge of writing the disk because everything is memory driven. You have much more processing capabilities as well. Again, I'm going to get you some things. If you think about your traditional Hadoop versus Spark, one thing which Spark got rid of is the MapReduce. If you think about MapReduce, is a fantastic solution at the time it came in, but Spark doesn't use anything related to MapReduce. It basically uses a different methodology using RDD. So from a performance perspective, as of today, pretty much even moving forward, Spark is in terms of number 1 in terms of how we can process massively processing systems at high speed. That's why you see Hadoop is massively challenged. That's why you see Cloudera and Hadoop Hortonworks are struggling to have that the amount of power they had before. But yeah, it's a whole new equation which was brought in by Spark. So yeah, so hopefully that answered the question. If not, I can always take some time and then explain to you later. I think one other question is, I'm just reading the question. Ajit mentioned okay, price point we spoke about, and we also, okay, in the context of data warehouse, one would not want to do extracting, scrubbing of, okay, I think that answered the question as well. So yeah, so let's coming back to this from a SQL database perspective, security plays a major role. So let me cover a couple of key points, right? So it's got built-in capabilities like built-in intelligence, because one of the things of data modernization we talk about is a lot of the services are going to come out of the box without you adding into it. Because the reason, if you think how it's possible, because the services managed by Microsoft, we give you the best of the world to make sure that all the services are available for you, and also SLA, right? The one of the reasons why people go into cloud is, I would say, the commitment for making your service available with contractual obligation, right? When you say, you know what, this service available with SLA of 4 nines, which means we will have a financially backed support. If you don't meet the support, you get some dollars and cents back. But more than that, right? So the cloud world, these services are built with high capabilities. So, and also it's baked in DR resiliency baked into it. Like, for example, if primary region is down, if you have replication enabled, your secondary region database is available for use. And also from SQL Server, we spoke about compatibility. As a customer, when you move into the cloud world, we guarantee you the compatibility with certain versions of SQL. You can't run like SQL 7 and then expect you to have compatibility, but there are certain thresholds. But yeah, so hybrid benefits, we call them hybrid benefits. If you have existing licenses, you can actually carry over to Azure, which means you'll save money on the licensing as well. Again, on the SQL, this is SQL database MI managed instance. There are 3 categories of it. One is general purpose. Okay, so so what we mean by general purpose is like basically based on your types of computer tier you want, which is the CPU cores you want. You have a capability of storing up to 8 terabytes of data store. This is most of the time customers use it. We also have Hyperscale. Hyperscale is about 100 terabytes of data store. And within that, we have one more offering called business critical. So the difference between the general purpose and business critical is wherever you need higher IOPS, you know, if you have some application needs a certain type of IOPS, you can go with the business critical as well. So again, 3 types of data stores based on your business needs. You can choose what is necessary for you and go from there. Again, Hyperscale is a service where we can store up to 100 terabytes per data store. This again talks about the engineering, which is also the pattern we choose on this particular Hyperscale is we have additional compute layer that can read only. If you see, even if you take a SQL Server, right? When you design your SQL Server, you can dedicate some nodes as read-only nodes. Some nodes can be read-write, and also standby, depending on how it is basically it baked into the platform itself. And if you think about where Microsoft is going with this solutions, we also started introducing SQL Database Edge. So if you think about Edge, Edge could be, can be not connected to your primary data store, primary data center. Think about Edge like 5G Edge, where or anything which is which can operate on a disconnected mode. If you're building a mobile application, if you're building something related to an IoT scenarios, that's why the SQL Database Edge comes into play. And as you can see, it supports ARM64 and Intel 64 devices on the Edge gateways. These are small form factor devices that can be has got the ability to deploy the SQL Edge data stores as well. Again, the same SQL technology is used to extend the databases into the modern way of edge computing. So that's something to think about. Is if you think about data stores, you also need to think about how you're going to build applications for non-traditional form factor type applications moving forward. So I think we spoke about earlier in this case, edges towards 5G. It's a very light engine, as you can see. It's tuned to run on ARM and Intel devices. The database engine itself is just 500 MB. So, and serverless again, databases tend to be very server focused. With this offering, we are starting to look into serverless, where customers have additional capabilities, not like traditional databases, where They don't pay for the entire the compute and everything. It's basically on-demand type store, which all of a sudden you're making your database also behave like functions or Lambda. So that's another new innovation we're bringing into the marketplace, where if you think about the offerings, it's a traditional data center-based deployment to the managed instance, to the edge, and now serverless. I think again, these are brought for customers so that with irrespective of where you're building an application, where you're hosting the application, what you're doing with it, you have the same capabilities across all spectrum of computes, be it a single processor compute sitting on the edge to a massive data center, right? So where are you going with this? From the customer point of view, from the management capability and the developer experience perspective, you have the same type of product available in multiple different type of devices, application servers. From a time to market perspective, this makes your life easier, and also manageability and everything is basically coming through a single pane of glass through the Azure. This is again, we spoke about earlier. It's about hosting your SQL on a virtual machines. I think now we're going into details on the MySQL, Postgres, and MariaDB. If you think about the origins of the MySQL or Postgres, Maria, they all come from the open source community, where it's an open source project, and that got more traction. When it got more traction, a lot of customers adopted it and become an enterprise product. One of the key value add we provide is these services tend to be supported by different frameworks. Some frameworks are basically not very widely known, but still customers need to support it. If you think about scalability, right? So traditionally, if you want to scale out MySQL, you have other challenges of adding servers, managing it in the cloud world. Because the way it works, you can scale out using configuration without you adding any additional servers. And security and compliant is basically natively available out of the box. When I say natively available out of the box, every time I deploy a service within Azure, there are certain things which comes on top of it. Identity, we can attach this data store into an Azure-based identity or on-premises identity. From all the storage in Azure are encrypted with the SHA 256 and above, and also it's got very strong identity logging, monitoring, alerting processes, and it also has got features like advanced threat protection, the encryption at rest on data, and also it also has got additional Azure-based policy management. There are tons of features which is we make it available, and the last one is reach, right? As a customer, when you're building these services, you should be able to have the ability to deploy this service based on your customer location or based on your needs. So from availability perspective, we have one of the largest number of data centers in terms of availability. We offer this service across the globe. So
Krishna, we have a question from an earlier slide.
Yes.
From Ajit. What's time series?
So time series about, let me give you a simple example, okay? Let's say if you're using 407 ETR, okay? So, and then at the time, for example, when you want to query, okay, within this last 10 minutes, tell me the number of blue cars have passed, okay? So in that case, the query that you do is, it's very different in terms of other queries you do. So what time series gives you is, it will plot the data across given every single time or time entry. So which means when you run a query, you can do time-based querying, so which means, give me X number of objects that has been passed through within this 5 minutes. Simple example, like, show me all the entries or show me all the logs, show me the CPU utilization of this service within this time period, right? So the time series databases are very verbose, where they capture multiple different things, but every single entry is attached to a given entry in the time, and that also gives you very different capabilities. Like for example, IoT devices are basically are tied to the time series databases, because IoT devices tend to be offline most of the time, and they want to synchronize with your main servers. We use the time series databases as well. Again,
also, this is Partha.
Yes.
Apart from that, time series is also used in data warehousing, where when you're doing data analysis on data cubes, you would look at a time series for things like retail operations or profitability of the store and so on.
Yep, that's a good point, Partha. Thanks for that. Basically, one other way I try and explain is all the entries are indexed through a timestamp. So, which gives you, if you think about other databases, we might look for customer information, you have a customer key, but here in this particular scenario, every single thing goes through by timestamp. So let's say if you take my session today, I started at let's say 10:30 to 11:30. If you compare me with at 10:55, what did Krishna talk about? So think about that's like an entry for every minute. I have an entry into the database, which means you can query. Show me the last 5 minutes of Krishna's presentation between these time zones. So it's a whole bunch of things. We also have products like Azure Time Series. And also we have products like Stream Analytics, which are basically built for it. The classic example I always tend to give is 407 ETR, where if you want to do some analysis on given slice of time, what happens. So that's how it goes into it. Okay. So Shad, what time? Sorry, I totally for 11:35, right?
Yeah, we have time to 11:45 because that's
Okay.
1 hour 15 minutes. We have 10 minutes. I need a couple last few minutes. You may need to make the announcements Khader wanted.
Okay, fantastic. I'll do that. I think I need to sum up on a logical end for this, and then I can continue the next week. So one key point to mention, I was mentioning earlier, right? The versions. Okay. When you support MySQL, Postgres, and MariaDB. So what we have done is we have taken hey, you know what? I will support 3 or 4 versions of it. SQL 5.6, 5.7, 8.0 are the ones we support at this point in time, and also keep very clearly understand that also the DB engine we use is InnoDB. So depending on your use case, that's InnoDB is widely used engine across the board. So if you think about Postgres, we support 11, 10, 9.6, 9.5. And MariaDB we support 10.2 and 10.3, right? So if you're wondering, you know what, I don't have these versions of this. The only way you can we're going to support you is you need to move to the certain version, and only then we're able to move them into Azure. Anyway, it's not a huge if you, for example, a lot of customers, what they do is they might not be on the current edition of it. They tend to deploy the same version on Azure. Once they land Azure, they will make sure they upgrade it to the supported versions of it. Without this, we won't give you. I mean, the databases won't work, but there's always a migration path we can do that as well. And it varies. We always keep our customers updated on what versions we support. So in summary, basically, it's a managed service. When I say managed service, it's available through Azure portal. And it also, we provide you the product support, as well as we also keep the versions upgraded to the latest editions as and when they become GA. The way we brought Postgres is we acquired a company called Citus, I think a couple of years ago. So Citus has been one of the leading developer for the Postgres highly managed service. So one of the features that comes within the Postgres is the ability to hyperscale. And also one other things also a key advantage of this one is able to process billions of rows of data without having to worry about scaling thing, right? So previously, one of the challenges we had with Postgres is if you want to scale out, again, you need to buy hardware, software. With this one, is basically the scaling is baked into it. Not only for this, the scaling, even for the managed instances and MySQL and MariaDB, the scaling is baked into the core platform itself. That's one of the reasons customers go from unmanaged to managed, just for the fact you have the ability to scale the service on demand, just like you do a web service, or just like you do a web server. And there are 4 ways. The reason I'm bringing open source here is Microsoft strongly collaborates with open source systems extensively. The first, we want to enable developers, partners, and most importantly, enterprises to the investment they made on open source. We want to make sure those investment are protected. For example, we support 8 or 9 types of Linux. We support Docker, PHP, Java, Node.js. It doesn't matter what you have. You'll go. You'll always have a supportability from the perspective, which means as a customer, your investments on these open sources taken care. And we also integrate extensively, right? So, for example, if you think about Redis Cache, okay, Redis Cache, what we done is we taken the open source product, we made as a platform as a service. At the same time, if you are Redis Cache also have their own offering on Azure, which also works extremely well within our ecosystem as well. So, and additionally, we also, when we build it, we also contribute the code back to the open source ecosystem, right? So basically, where we learn from the open source, we make it better and we put it back. So that way, this gives you a very strong cycle of innovation as well. And release, when you say talk about release, within the Microsoft ecosystem, we have things like, Visual Studio Code is one of the widely used open source product. We also have .NET Core, which is also an open source .NET engine. We also talk about the Fabric. So we also release a lot of our Microsoft products into the open source world. That also gives one advantage where if you're an open source developer, you can take the source we provide and build additional top of it, and contribution we constantly add based on our. If you think about Kubernetes, Microsoft is one of the top contributors for Kubernetes ecosystem. So the whole idea of Microsoft at this point in time is it's not only take advantage of open source systems available, and also we are also strongly contributing back to the ecosystem so that the ecosystem can grow better and better. So, Shad, I think we have 5 minutes now. Maybe should we start with the announcements and then
Yes.
So so next week there's no class. So we have another session that is industry focused session. So we will. One of the ask is to enroll for the session through the Eventbrite. If you, Shad, do you have the link that you can share to the participants, or we can get it later?
I'll put the link on the chat for everyone to have access to. So this is for the next week's meetup event.
So next week meetup is also happening at the same time. So I think that's why we don't have any class next week, but the following week we will have it. Shad, do you have you sent the link already? Yep.
Yes.
Yeah. If you go to the link, please enroll for it, and then.
So the direct links also to the particular event is also posted.
Okay. So we have 3 presenters next week. One is Dhruv Chandra. So Dhruv works with RBC. He's the head of cloud governance and compliance. We also have Brian Lee. He's the founder of the Cyber Career Center, and Derek Kerr from Microsoft Technology Center. He's an architect, security architect. I know he has worked with a number of federal security work, and then he's one of I would say topmost security architect. Dhruv is a very good friend of mine. He has been in the financial industry for last decade or so, and his primary focus is cloud governance, security, as well as building governance policies for financial industries as well. Next week is going to be a fantastic section. I think Brian Lee, he hosts number of events like this, focused purely on cybersecurity. So if you want to enhance your knowledge and things like that, I definitely recommend you guys come and join these sessions, And they are fantastic presenters. They have been doing this for a number of years. I would definitely, spend some time to at least attend it, or you can do offline too. So yeah, I think that brings us to 2 minutes left. I was hoping to finish this by this week. Looks like it's becoming a normal pattern. Next time I'll make it faster and then go from there. If we, as always, if you find this useful, let us know. If you want me to improve or fix the flow, let me know. But I'll share the decks earlier. So one thing I want to mention is these are individual services. I will work with my team with Desktopper to give you an enterprise cloud data strategy framework. The framework idea is to how does enterprises can move the on-premises data assets or estates into the cloud, and what patterns and practices can be followed. So that's one of my after I finishing the session, I'm planning to give that. I'll also do a cloud adoption framework, which is Microsoft has built from scratch. How does for enterprises how to adopt cloud patterns and frameworks into an enterprise world. So with that one, I think we are right on spot. Shah, thanks for jumping in, and thanks for Ajit, Hetal, and and everyone to that contributed the question. But thanks always, for taking time to attend. It looks like a sunny day as well today. So
yes, it's a lovely day outside today.
Yes, which also means you need to mow the lawn because I already 3 weeks ago. So thank you guys, really appreciate it.
Thank you everyone. Thank you for joining. Thank you, Krishna.
Thank you, appreciate it. Thanks. Bye.